So today we're going to be working on rotations, and if you remember what we talked about last week, a rotation is where you are turning a figure, and usually you're going to turn it maybe around some type of fixed point. And so for this lesson we're going to be primarily working on rotating figures in the coordinate plane, which is on just your typical graph that you see. And so the point that you're going to be rotating it around on the graphs that you kind of see down here are going to be, it's going to be the origin that you're rotating it around, which is that middle point of your graph, okay? So we are working on how to rotate figures in the coordinate plane, okay? So to be able to do that, you need to kind of understand a little bit more about rotations. And so there's this thing called the angle of rotation, and that's going to tell you how much to rotate that figure. And it's going to be expressed in degrees. So the angle of rotation is the degree you rotate the figure. And in this class, we're going to focus in on certain types of degrees, okay? You can rotate something 1 degree, 2 degrees, 3 degrees, but for the sake of this class, there's certain ones we're going to focus in on. So the different angles that we will be rotating things are, you can rotate something 90 degrees, which is kind of like a quarter turn. You can rotate something 180 degrees, which is kind of like a half turn. So it kind of turns the figure upside down in a way. You can rotate it 270 degrees, which is 3/4 of a turn, if you kind of think about it. And then you can rotate it 360 degrees, which is all the way around. So you might hear somebody say, I did a 360. That just means that they turned all the way around, okay? Now, if you notice, these go in increments of 90. So like if I take 90 and I add 90, I get 180. If I take 180 and I add 90, I get 270. If I take 270 and add 90, I get 360. So we're kind of focusing in on the 90 degree turns, or the quarter 1/4 turns, okay? So sometimes you might see that they will keep turning it, and so if I take, for instance, 360 and I add 90, you would get 450 degrees. So that would be kind of like turning it all the way around and then another quarter turn, okay? So that's where you would end up if you rotated it 450 degrees. And if I went again, if I added 90 again, I would end up at 540. So the thing I need you to realize is sometimes when you see these, you just have to figure out kind of how many 90 degree turns do you have to take to get there. And so if you kind of think about it, 450 degrees is actually the same exact thing as if you rotated it just 90. Because if you think about it, it's where you've kind of 450 is where you have rotated it all the way around, but then you went another 90. So that's actually the same thing as 90. And then kind of for the same reason, 540 degrees is actually the same thing as a 180 degree turn. And so if you kind of want to play around with that, you could take a figure, or like for instance, I could take my graph paper and just kind of practice rotating. And so like if I rotated it from where it was right now, 90 degrees, that would be a quarter turn. So 90 degrees would look like that. If I took it and rotated it another 90 degrees, in other words, just turned it kind of completely upside down, it would look like that. So that's 180 degrees. If I kept going and rotated it another 90 degrees, that's 270. If I rotated it another 90, I'm actually back to where I started, so that would be 360. And so I do encourage you to take something right now, so pause the video and just kind of practice it turning every 90 degrees and figuring out, okay, what kind of rotation is that? Because in a minute we're going to come back to this and we're actually going to be rotating to figure out what are called the rules of rotations, okay? And so take a moment and do that, all right? All right, so now that you have had some practice with rotating it, let's talk about the different ways to rotate the figures, okay? So there's two different ways or two different directions in a way that you can rotate it. You can rotate something either what's called clockwise, or you can rotate it what's called counterclockwise. Okay, so you'll see that they abbreviate clockwise with just a CW for clockwise, and then counterclockwise they're going to abbreviate as CCW for counterclockwise. Okay, so clockwise actually goes the same direction. Like if you look at a clock, if you look at, sometimes it helps to look at the second hand of the clock, it rotates clockwise, and so clockwise kind of goes the same direction that you would see a clock goes. It goes in this general direction. So if we kind of drew that, it would look like that. So if you started here, it would be going in that direction circle-wise. Okay, so then if you go counterclockwise, that's actually opposite of the clock. So it actually goes the other way. So if you aren't sure about that, you could look at a clock, look at which direction it's going, and then go the opposite way. So counterclockwise would actually go this way. So it kind of goes in that direction. All right. So clockwise goes with the clock, and then counterclockwise goes opposite of the clock. And now, usually in these problems, it will tell you which way to turn the figure. It's going to have to tell you kind of whether to rotate it clockwise or counterclockwise. But if it does not mention it, then the default, the way that you should be rotating it is actually counterclockwise. So maybe put like a little star by counterclockwise so you can remember that if they don't tell you which way to rotate it, then just make sure you're rotating counterclockwise, which would be the opposite of the clock. So if you like pull out your figure that you were rotating a minute ago, clockwise would be in this direction. So notice that's going the same direction as the clock. And then counterclockwise would be the opposite direction, so that it would be if I'm turning it this way. Okay, and so if you want to practice that would be a good idea. Okay, so now let's talk about how to actually rotate figures when it comes to rotating them on the coordinate plane. There's actually a couple ways to do it, but for the sake of this class and what you're supposed to be learning, we're going to concentrate on how to rotate them by finding the rules first, okay? Because we've been talking about how to find rules in this class, all right? So to rotate a figure around the origin, I told you that's usually what we'll be rotating around on the coordinate plane, the first thing that you have to actually do is get the rule, like what is going on when you rotate it, however many degrees you're supposed to rotate it. So what you're going to do is actually go to a separate graph paper. So you're going to grab a graph, kind of like I have with me. So if you don't have a piece of graph paper, go ahead and get one. And then you are going to use that point that we used for reflections to help you get the rule. So that point is that all famous point that really isn't that famous. We just use it because it's kind of easy to tell what's happening. But you're going to rotate the point 3, 5 to see what's going on. So like if, for instance, they told you to rotate it clockwise 90 degrees, you're going to graph the point 3, 5. You're going to rotate that graph 90 degrees clockwise, and then 3, 5 you'll notice actually land somewhere else on the graph, and then you're just going to see what happened to that point. Okay, so you're going to rotate that point 3, 5 to get the rule. And then after that, you'll have the rule, and remember the rule tells you what's happening to your x and y values, so you'll know specifically kind of what do you do to your x's and what do you do to the y's to rotate it. And then all you have to do is apply that same rule that you just got, because it'll be true for anything that you rotate that many degrees. You apply that rule to the points that are in your figure, and then you're done. You have rotated that figure, okay? And then if you have to graph it afterwards, you can graph it. All right, so we're going to practice that, so I'm going to just show you kind of a little example here so you can see. So like for instance, let's say that they tell me to rotate some figure that's being graphed 90 degrees clockwise, okay? Before I even look at my problem or the coordinates of my actual figure, I'm going to go to the side like I did here. I'm going to graph the point 35, 1, 2, 3, 1, 2, 3, 4, 5. And I'm going to rotate that point, or this graph in general, 90 degrees clockwise. So remember, clockwise goes the same direction as the clock, so that's where the direction I'm going is kind of this way. And then I'm going to rotate it 90 degrees. So 90 degrees is like a quarter turn. So I'm going to rotate it clockwise 90 degrees, so that's a quarter turn. And notice if I kind of look at this graph like a normal graph, so like this would now be my x-axis and then that would be my y-axis, I'm going to look at what the coordinate of that point is now if I look at it kind of like a normal graph. So I'm going to look, okay, what is the coordinate of that point? Well, and if you need to write it down, you can. So I'm going to go 1, 2, 3, 4, 5. So that's 5 to the right, 1, 2, 3 down. So I have to go right 5 and then down 3 to get there. So that's where my coordinate landed. Okay, so then how do you use that to get your rule? Okay, so think back to what it originally was. It was originally the point 35. And then after you rotated it, it landed at 5, negative 3. Well, what happened to your x's and y's? Well, this was my original x and y coordinate. Well, then what happened? If you notice, the 3 and the 5 actually flip-flopped. So the x and the y, you're going to have to actually flip-flop. So it's going to look like that. But then if you also notice something that's different, that 3 is now, or it now has a different sign. And so that x value not only flipped kind of to the back, but now it's got a different sign. So to show that it has a different sign or that you have to change the sign, you actually put a little negative in front. And now that doesn't mean that everything's going to just become negative, because if it was negative to begin with, you would actually make it positive, okay? What this actually means is you're taking that number, whatever that number is, and you're multiplying it by negative 1, okay? And so you can think of it kind of two ways here. Number one, they flip-flop, so the x's and y's. So x and y switched or flipped, so however you want to think about that. And then the x value not only flipped, but it changed the sign. And so you can think about it like this, kind of in words, or you can think about it in the rule, but now you have the rule. So after that, you would go to your actual figure and the coordinates in your figure, and you would do exactly what this says. You would flip each of the x and y's and each coordinate, and then you would change the sign of the x value. So whenever you bring that x value to the back, you would change the sign of it, okay? So let's practice a couple problems so you can see how that works. All right, so number one, it says triangle ABC is rotated 180 degrees counterclockwise. Write the rule and the coordinates of the image, okay? So before I'm actually going to look at my figure, I'm going to figure out what is the rule for when I rotate something 180 degrees counterclockwise. So I'm actually going to do what I just did a second ago so that I can figure out in general when I rotate something that many degrees, what happens, okay? So I'm going to pull out my handy dandy graph, okay? I'm going to use the 0.35 just because it's easy to kind of see. Notice it has nothing to do with my problem, okay? I'm only using the 3.5 so that it can, because it's easy to work with, okay? So I'm going to graph the 0.35, 2, 3, 4, 5. And then I'm going to rotate it what it tells me to rotate it. So we are rotating at 180 degrees counterclockwise, okay? And so if you want to go ahead and put the original coordinate and then put where it lands afterwards, you can, okay? But let's do it. So counterclockwise is opposite of the clock. So like the clock goes this way, so I'm going to rotate it the opposite way, okay? And then 180 degrees is literally like turning it upside down, so you can think of it that way, or it's like two 90-degree turns, however you want to do it, okay? So I'm going to rotate it a quarter turn, that would be 90, and then I'm going to keep going another quarter turn, and then that's 180. So now I'm going to look at the graph like it's a normal graph, and I'm going to tell where it lands. So it lands at -3, -5. So I'm going to write that down so that I don't forget that. -3, -5. And then I'm going to kind of turn it back so I can see what I did. And I'm just going to copy that here, and then I'm going to look what happened to my x and y values. Okay, well, that's my original x and y value. Well, what happened to it? What changed whenever I rotated it? Well, notice the x and y's didn't switch places this time, but the x value, the sign changed, and the y value, the sign changed. So to write that, like I said before, if the sign changes, you just put a little negative in front of the whatever it changed with. So it changed with the x value, and then it changed with the y value. So that is actually the rule that you can use anytime that you rotate something 180 degrees counterclockwise. This will actually be what happens to any coordinate that you do that with, okay? So now that we have the rule, that actually makes this problem really easy. I know in general that anytime you rotate something 180 degrees counterclockwise, that's what's going to happen. So I'm going to take each of these coordinates and I'm going to do this with them. So all I have to do is change the sign of the x value and change the sign of the y value, and I'll have it. Okay, so let's see, where is A prime going to land? Well, the original A was at -4, 0. So if I change the sign of the x value, well, my x value is -4. It's going to become a +4. And then if I take my y value and change the sign, it becomes, well, if I change the sign of 0, it's still 0. So that's where A prime would land. So now I do the same thing to B. So I'm going to look at B. That's where it originally is. And what I have to do is change the sign of the x and the y value. So if I change the sign of the x value, it ends up at +3. If I change the sign of the y value, it ends up at -5. So that's where B prime would land. And then same thing with C prime. I'm going to take that, I'm going to apply that rule to that coordinate. So 4 will now become -4. And then 1, if I change the sign of that, it becomes -1. Okay? So if I take that figure and I rotate it 180 degrees counterclockwise, this is where it's going to land. And notice you can actually kind of eyeball it. Like if I take my entire paper and rotate it that many degrees, you can kind of see where it's going to end up, but this would be the exact coordinate. So like if I'm going to take my paper and I'm going to flip it upside down 180 degrees, that's actually kind of what it's going to look like when I graph it. So you can kind of see, just to make sure that you've done it correctly. But let's graph this and just verify it. So A prime is now at 4, 0. So 1, 2, 3, 4. That's where A prime lands. B prime is now at 3, -5. 1, 2, 3. 1, 2, 3, 4, 5. And then C prime is at -4, -1. So 1, 2, 3, 4. -1. So that was A prime. That was B prime, and that was C prime. And notice, if you kind of think back to when I flipped it or turned it upside down a second ago, it kind of looked like that. So there we go. There is the figure after that rotation. Okay. So the next one, it says you've got a trapezoid and it's going to be rotated 270 degrees clockwise. It wants you to write the rule, and then it wants you to find the coordinates of the image. Okay, so I'm going to take before I can actually do anything with my figure, I'm going to take the graph paper. I'm going to find the rule by graphing the 0.35. So 3, 1, 2, 3, 4, 5. And then I'm going to rotate that 270 degrees clockwise. Okay, so clockwise goes with the clock, and then 270 is like 3 90-degree turns. Okay, so clockwise, that would be 90. That would be 180. And then that would be 270. Okay, so I'm going to look at it like a normal graph. So that's my X, that's my Y, and I'm going to tell where it landed. So let's see, it's now at 1, 2, 3, 4, 5, negative 5, 1, 2, 3. So negative 5, 3. And again, I do like to write it down because it's kind of hard for me to remember that, and that way I have it. So 3, 5 became negative 5, 3. So now I'm going to look what happened to the X and Y values. So notice for this one, they flip-flopped because my Y is now first. So I'm going to flip-flop my X and Y. And then now in this one, the 5 changed signs, and that was my Y value, right? So not only did I flip-flop them, but then when that Y value came up here, it actually changed signs. So I got to put a little negative with the Y. So there's my rule. Okay, so now I'm going to just copy that down so that I can remember. So, and you can think about it in words. So I had to flip-flop them, and then you change the sign of that Y value when you bring it up front. Okay, so now I'm going to do the same thing to each of my coordinates. And if it helps you to kind of write the coordinates down like the original one and then write down where it lands, that's always a good option. Okay, so I have to flip-flop them. So the negative 9 and the 3 will flip-flop, and then that Y value I have to change the sign of. So if I do that, the 3 and the negative 9 flip-flop, and then I have to change the sign of the Y. So that 3 will now be a negative 3. And then, okay, so the X was originally at negative 6, 6. So then where would X prime land? Well, I've got to flip-flop them, and I have to change the sign of the Y. So when I flip-flop them, the 6 and the negative 6 flip. And then that 6, which was the Y value, not only did it kind of flip-flop to the front, but now it's going to be opposite sign. So it's got to be a negative 6. The Z was originally at negative 2, 6. And so where did Z prime land? Well, Z prime, well, I got to flip-flop them, and then I changed the sign of the Y. So if you wanted to do it all together, that 6 comes to the front, and you have to change the sign, so it becomes a negative 6. And then that negative 2 just goes to the back because the X didn't actually change sign, so it stays the way it is. Okay. And then the last one, the P, was originally at 1, 3. And so P prime, flip-flop them, and change the sign of the Y. So it would now be at negative 3, 1. Okay, and then if it wanted you to graph them, you could graph them, and it should look like it's been rotated clockwise 270 degrees. So like if you took this one and rotated it, it like turned your whole paper. So like that would be, whoop, that would be 90, that would be 180, and then that would be 270. That would be kind of what it looks like if this was like your normal graph. Okay, so there's going to be some situations where they give you the rule, and if they give you the rule, like in number 3, if you notice they give you the rule, then all you have to do is apply that rule. Okay, and then it's saying they want you to describe the transformation. So if you look at the picture, you can kind of usually describe it pretty easily. So to describe the transformation, we're going to graph the original. So A would be at 1, 1, B would be at 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. C would be at 2, 13. I think that's going to go off of my graph, but it's okay. So 2, 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be like right here. I'm going to put a little line so that I know where it went. Okay. So that's C. Let's see. This is A and this is B. And so I'm going to apply my rule and then I'm going to graph where it lands, and I'm going to see what type of rotation it is. Okay, so I'm going to have to kind of observe it. So my rule is you flip-flop the x's and the y's, and then you change the sign of the y. Now, if you kind of already found that rule in another problem, we actually noticed that's the same rule we just had. So if you realize that, you already know the transformation. But if not, this is the other way to do it. So I'm going to apply it like I did before. So I'm going to just apply this rule to each coordinate. So A prime, got to flip-flop them and change the sign of the y. So if I flip-flop them, it's still 1, 1. But then I have to change the sign of that y when I bring it up front. B prime, flip-flop them, change the sign of the y, would be at -3, 6. And then C prime would, same thing, flip-flop them, change the sign of the y. So it'd be -13, 2. And then I'm going to graph it, I'm going to see where it lands. So -1, 1 would be right there. And I'm actually going to move this so I don't get confused. Move it right there. That's A prime. And then B prime is at -3, 6, so -3, 1, 2, 3, 4, 5, 6. And then C prime is at -13, 2. So -13, 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, and then 2 would be right there. Okay, so that's my C prime, that's my A prime, that's my B prime. So I'm going to kind of rotate my paper and see when this original figure, ends up looking in that spot, okay? And you're going to notice there's actually 2 different answers that will work here, okay? And actually there's more than that, but I'm going to just go with whichever one you tell me. So like notice, if you realize that you can just turn your paper this way 90 degrees, you'll see that that actually ends up where this one was. And so 90 degrees counterclockwise would actually make it match up. So that's actually an option. Or if you look at this and you rotate it clockwise, well, it didn't end up looking like it there. So that's 90. Didn't end up in the same spot there. That's 180. And now it looks the same as kind of where this one was. Then you would also know that that was a 270 degree turn. So if you rotate it 270 degrees clockwise, that also puts it on it. So this one had 2 different answers that would have worked. Okay, so it says for this one, write a rule. So you have to write the rule that will map, and it just means making it match up like we just did. The pre-image, so this is the pre-image, onto the image. So you could kind of figure out what type of rotation that you would do for that one, or you could pick a coordinate. So I'm going to pick like the coordinate, let's pick a good one. Let's pick the coordinate M, and I'm going to see where it originally was. So M, 1, 2, 3, 4, 1, 2, 3. It was at -4, 3. And I'm going to see where M prime landed, and then kind of like what I do with the 0.35, I'm going to see what happened to my X and Y's, and then just write it as a rule. Okay, so M prime ended up at 1, 2, 3, -3, 1, 2, 3, 4, -4. Okay, so this one's a little trickier, but you're going to look what changed between your X's and Y's. So, okay, so my X and Y originally was -4, 3. Well, what happened? If you notice, they did flip-flop, so the X and the Y's flip-flop, so that's one thing that happened. But what else happened? Well, that -4 stayed a -4. It just went to the back. But if you look at that 3, it actually changed signs. So your Y value changed signs. So there is your rule. Okay? So that is how you rotate figures. Okay? And how you get the rule to rotate them.